So today we are going to work on a Wireshark tutorial. So as mentioned yesterday, um, I had asked you all to bring your laptops and if possible, please start downloading Wireshark. Okay, if you have already done that, good. Okay. So today we have our research scholar Elena Sinha with us, and she will be giving you a brief overview on Wireshark and how to use it for different questions that we have already prepared. Okay. So before we start the class, so I just want to make a few announcements. So tomorrow there is the schedule is like 11 to 1. There is a class by Dr. John Jose, and day after tomorrow we have an exam. Okay. Once you give the exam, then the certificates will be given. Okay. So I'm sure that you have already been told some of the data that we require from you. That is, your some details and passport size picture probably. So that will be conveyed to you later on by our volunteers. Okay. All right. So yeah, over to Elena.
Thank you, ma'am. Thank you everyone for your patience and time. So before we delve into Wireshark, let's speak about the water shark. So we all know the animal, the shark, which stays underwater in the ocean. So what does the shark usually do? Like we have seen movies, Jaws. Yeah, it hunts for its prey. And the way it does is that it tries to sniff blood and it goes towards its prey. So Wireshark, thank you everyone. Sorry for the technical glitches and thank you for everyone for coming together. So just like the water shark, Wireshark does the same thing. So it sniffs packets on the wire, on the network, and then it tries to capture them and analyze them. Almost parallel to a CCTV camera. So a CCTV camera records everything that happens. Let's say we go in an airport, so it will capture every person that comes in and out. And whenever required, we can obtain all the details and study every person's movement inside the airport. So that's the analogy. So we say that in networking, the connections may be temporary, but packet capture is permanent. So Wireshark was born on 2nd May 1998. Previously, there were many networking tools, but they were closed and very expensive, and not many people could access them. In 1998, Gerald Combs, he made Ethereal, which was open source, and it suddenly, he tried to solve a personal problem, but that it suddenly became very popular. People tried adding patches to it, and then a lot of global contributions happened. And today, whatever we see is the Wireshark. So it's so popular that every month we have around 40,000 downloads. Let's see how Wireshark sees the packets. So if we see the protocol stack, we have the application layer, the transport layer, the network layer, and the link layer. Wireshark taps into the packets at the link layer level. So we have an application layer message, which at the transport layer we add a header, and then we see a transport layer segment, which then gets passed on to the network layer, and from the network layer, the link layer collects the network layer datagrams, and then that is what the Wireshark taps into. So let's see how Wireshark captures and analyzes the packet, the structure. So we see that there is a device and the packets travel to and from the device. On the extreme left, we have the protocol stack. So the application layer is at the user space, and then we have all the other layers. We see that Wireshark takes copies all the link layer frames and keeps them in a file called the packet capture file, also known as the PCAP file. Apart from that, we also have a packet analyzer, which is very important to us because that is where exactly we see all the details of the frames and all the TCP segments, all the network layer datagrams and details. We'll shortly look at that. So let's get started, and before we fire up Wireshark and see how it is, let's try to get introduced to some of the interfaces that we'll be seeing there. Meanwhile, we can maybe download it in our systems and look through. If you want, then these are the installation steps on Ubuntu and Windows, but I guess we can carry forward. So when we open Wireshark, when we fire Wireshark, we usually have two panels. The topmost panel has the PCAP files that were saved previously. Since this particular Wireshark version is downloaded very recently, we do not have that panel. Beneath it, we have all the link layer interfaces like Wi-Fi or Ethernet. The squiggly lines that we see are those packets that are captured. Maybe we can select Wi-Fi. Once we open, we have the menu buttons. The two most important buttons are on the top right. The blue shark-like fin, which when we start, it captures the packets, and then the stop button, these two buttons are the ones that we will be using mostly. We also have all the list of packets that are captured. We can maybe stop it, select a packet, and all the details of that particular selected packet is what we see in this screen. And the details of those packets in ASCII or hex can be seen in the right hand panel. So as a first exercise, let's try to see the network statistics, and we'll try to see the throughput, round trip time, the average packet size, number of packets lost, and the number of TCP and UDP packets that were captured. For that, let's try to open a browser first, and hopefully we'll capture some HTTP messages. Say we open iitg.ac.in. So we can check the network statistics. Once we see the net stats, we see all the TCP packets, the number of packets that were received, the header errors, the datagrams that were forwarded. We can go to TCP. The number of segments that were received, sent, and retransmitted because they failed on the way, and the current connections that are there. Similarly, to see the statistics on Wireshark, we can go to statistics, maybe input-output graphs. This is in packets per second. So to calculate the throughput, we can change the y-axis headers to bytes. Or we can even go to TCP stream graphs and check for the throughput. can't see anything. No idea why this is not firing up, but
Maybe open the Wireshark one. Suppose we open this one. Round of time. Because the X is very big, that's why it's not visible.
okay.
It might be somewhere.
Okay, maybe this is the configuration of the axis, but usually we can see the round trip time graphs and the throughput graphs here. Since Wireshark is installed very recently, I'm not able to fix this right now. But so for the number of packets lost, we can see that, or if we want to check the number of TCP and UDP packets, we can just go to the stats, protocol hierarchy, and maybe we'll see the number of packets for TCP and UDP. Here, I guess 98% of them are of TCP packets, but I mean no UDP packet is captured yet. Similarly, for if we want to calculate from that stats, we can get the input from the input bound throughput and the output bound throughput, and maybe we can calculate. Similarly, for the average packet size, we can see the particular values of these fields, and maybe we can calculate from there. Let's go to the second assignment, which is understanding TLS with Wireshark. So in transport layer segment, TLS, the client and server communicate, and they try to handshake and settle with a particular key or a particular encryption system. So to capture let's try to see a TLS handshake. TLS. We can go to the filter section and TLS.handshake. Dot type. Since we want to see the symmetric key algorithm that was used to encrypt the HTTP data, this will be done during the server hello. So we'll try to see the server hello messages. So type equal to 2, and we can see a server hello message. We can click on the triangle button on transport layer system. We have selected one message, and maybe we can select from the record layer handshake protocol the server hello. Is anyone doing along with me? Okay. All right. So we see the cipher suit, which is TLS AES 256 GCM. So AES 256 GCM is the one.
Okay, please.
Yes. So in TLS we have this client hello and server hello. So in client hello, a lot of handshake protocols will be sent by the client. The server hello, one will be selected by the server and it will be fixed. So once we put the filter as type 2, we'll have only the server hello messages. Now once we select this message, we can see the frames, the Ethernet, the IP protocol, TCP protocol and the TLS. So we can expand transport layer security. Is it done? Okay.
So everybody is done with this? Are you doing it together? Please do it. Yeah? Please do it.
Analyzing this topic.
Yeah, but we want you to also check that whether you are getting this answer or not. Okay, whether you are getting the same thing that is being shown in the screen, then only we will learn about it, right? So please.
Yes.
For you, yes. Yes, yes. So maybe I can go and check. Okay.
We can see that the transport layer version is 1.2. The random is the random number that will be used. Is anyone having a cipher suite that is different from this? Different handshake protocol?
0xC030.
0x?
0xC030.
No, the cipher suite. It will be something similar to this. Maybe cha-cha something. Okay, this is the one with AES 256 GCM. Someone else? Same? Okay. So let's see the other question in the slide.
Can we wait for a little bit more?
Yes, ma'am.
Let's see.
Can I go and check?
I can check. Please. Okay, now we can start with next one.
Okay. So the next question is, in which TLS message is the algorithm negotiated? So the negotiation happens in the server hello itself, which was discussed right now. What is the packet number of the first encrypted client or the server application data? First encrypted client to server application data. So we can put the filter number as 23. Okay, yes, 23. So we'll go for the record content this time, not handshake. So record content dot type equal to 23. And the first application data message will have a particular number, which is the packet number. Is everyone getting this number? Anyone higher than 146 or maybe much lower than that? Yep. Okay. So the next is what is likely inside the first encrypted application packet. So once the first encrypted packet will have some message, maybe an HTTPS GET message. The next is which packet shows the client sending a TLS shutdown message. For these we can see some alert messages. So we can go for the content record content type as 21 because they usually show the application alert messages. Is anyone getting this filled up? Okay. 1 second. Can we, I don't have those packets. Okay, but it's an encrypted message. Yes. Since Wireshark cannot capture encrypted messages, but the alert message is probably a shutdown, TCP shutdown message, TLS shutdown message. Anyone else who got it? No. No. So these are some filters that we can give. Just to show the client hello, we can see the select the type as 1. For the handshake type server 2, and if we want to see the change cipher specifications 20, 23, 21, and if you want to restrict it to only one single TCP stream, we can specify the number. So let's see. We can then go for the next assignment, which is exploring ICMP with Wireshark. ICMP is usually used for diagnostics of some, if there is some failure in a router or so through ping and trace routes. So
So anybody here does not know what is ICMP? No? Okay, have you heard of ICMP? Can you check now what does ICMP do? Okay, so it's a control message protocol. All right. So what you generally find out is that from one node to another node. Okay. In general, we check for trace route, etc. Right, when we use ICMP messages. That means number of nodes that are there in between your endpoint and the other endpoint that you are looking at. Okay. So please check. Sorry, what you are saying?
Is getting ICMP V6.
No ICMP at all. You are googling ICMP and you're not getting ICMP.
He's checking Wireshark.
No, I'm asking you Google ICMP and then you find out. Okay. So now what we are going to do with this Wireshark is that we are going to check that use ICMP. How does it just see that how the packets are getting traced here. Just take a look at it. So these are the few questions that we will try to answer. Okay, please read the questions here. Okay, so has anybody done a ping in their laptop's terminal? You have done. So what do you see when you do a ping?
So our laptop sends a packet and then they receive the packet.
Hmm.
Then they show the latency and the jitter and all.
Okay. All right. And what about you? You wanted to say something?
I was wondering if jitter is shown, but I mean you have statistics that are shown at the end.
Okay. Okay. All right. So Elena will now show you that what exactly is shown. Okay.
Can we maybe do an ICM ping and then maybe check the ICMP messages?
Check. Are you guys getting there? So when we show it, these questions, this is the question, this is the answer, this is the question, this is the answer. You guys are getting? Yeah?
Okay. So maybe can we go to Wireshark and type in our filter icmp.type equal to 8. So the question is compare packets from traceroute versus ping. So that will give the traceroutes from ICMP packets from traceroute. Is it populated in Wireshark?
No packets.
Can we check? Okay. Okay. And then maybe icmp.type equal to 11. Could you ping?
Yeah, so they are doing, what is the issue?
We need to ping first. No. Yes.
So the first row of ping, okay? if you wait, Lina, see, when you pinged it,
Yes.
last time, yeah. So when you are pinging it, please see that how it is, how the responses are coming from that side. Okay?
Yes.
Then you can check for the ICMP.type it. Why you are doing this ICMP.type it?
Just to see the trace route packets.
Yes. So for trace route, type equals to 8.
8. Okay. No. Okay, this is for trace route. The other question was, did it get populated for anyone? Type equal to 11. 11.
Some big question.
Sorry.
What does like code 11 mean
Sorry.
for type 11?
I didn't understand.
I'm saying like how will we get 11 packets? Type 11 packets. Like we ping now.
Yes.
So we got 8. Like
Yeah, we ping, but I don't know, the messages are not populated.
Can we try the next question?
Is there a hop with an unusually high delay in your trace?
Let's go to the trace route.
So we can go to the statistics and see the RTT.
I think you have to do a trace route again and then type it up. Zero DX getting the items. Group statistics. So can you put just TCP there? You know, remove TCP. Just TCP. Now you do statistics.
Yeah. So every spike or down point shows the RTT of the particular packet at the time.
Are you busy getting it? What? Yeah. What about you too? Did you get it? Alright, we can go to the next one.
So we can see what is the IP address of our host and target address. So maybe we can select a packet. expand the header. We can find the source IP and destination IP here. Can anyone check? Oh, it's there in the packet itself here. But how ICMP error messages are different from echo packets. So this is a theoretical question itself. And what extra fields appear in an error message? Why might attackers abuse, and how can network security tools like firewall or IDS limit ICMP misuse? So
these questions may be.
So yes, these are some key filters, and these are some points to remember, that it doesn't capture unencrypted packages. We should make sure that we don't have any VPN. We can either turn off our browser or OS privacy for that.
Let's see. So we have got some things. Quick. When you use quick, you have got some things, right? Can you do the same thing? Like, you found out a little bit of, all the questions that we have done with respect to TCP. Now let's check if we can do something with respect to quick. Okay. So what are the statistics that you can find with respect to quick? Can you tell me?
Statistics are in source destination.
Yeah. What else you are getting apart from source and destination?
Port, LED.
So
Check.
anything related to security you are studying? Anything related to security that we have studied yesterday? So what is the most important thing that you get it here? If you see, so it is using UDP, right? No. So it is using UDP, right? Okay, so quick is used over UDP. So yesterday what did we see? We have studied that TLS is the one that is used over HTTP with that. So we are basically using TCP, and on that the enhanced security protocol that we are using it is TLS. Okay, and quick is what? It is a security protocol used with UDP. Okay, so when you check that, so you will get that UDP is there. Then we have our basic statistics that is given here, the source destination side, and let's see if we can find something else here. Check the statistics. It's not coming up. No, UDP. It's not giving. Okay, let's see. We can go to conversations next. Conversation, we are not doing a conversation, no? Okay, let's see. Let's see, what do you want to say? What do you want to find out?
I think you can see something related to UDP, but nothing. Okay.
Hello?
It's okay, I think we can just.
Another?
Another is with. It's okay.
Okay.
We are done with the class.
Okay.
Okay, so essentially we are done with the class. Okay. Only thing is, if you have any questions and if you want to still go on with some of the questions that are there, you can just go ahead. Okay, we are here for some more time. Okay, thank you.
Thank you.